Hey everybody. So today I'm going to go over the differences between rag tuning and fine tuning. And this happens to be an area where there seems to be a lot of misinformation and a lot of overcomplication of these concepts. So I'll try to break this down for you as simplistically as I can and exactly how I look at it. So let's start off with two concepts. There's two concepts to understand that are important to this, which are word vectorization and embeddings. So starting off with word vectorization. Word vectorization is essentially how the model breaks down words. So an LLM model is a prediction model. It predicts the next token in a sequence. And a token is essentially words. We break words down into tokens. And it's not a one-to-one translation. Generally speaking, about 4 letters equals 1 token. And so what we're going to do, and the very first thing that I'm going to demonstrate here is exactly how this vectorization process works. Essentially taking a word or a sentence and then breaking it down into a token. And then so in this example, we have some sentences, and then we have a word that we want to illustrate being tokenized. So cat likes milk, dog likes bones, bird likes to fly, cat and dog are friends, and milk is good for health. The LLM model is not going to view this at all in any way like this. It will view the word cat as this vectorization here, 0.609814846, 0.0.0.3, etc. Right? And then so if I put a different word in here, like health, completely different vectorization, right? If I put dog, same thing. We can see that our vectorization is updating depending on the word that we're using. And then so this in this instance is TF-IDF vectorization. So this is standardized, right? So within TF-IDF vectorization, for dog, it's always going to be this. For cat, it's always going to be the same, etc. And then so that's how the models essentially utilize words. And then so this is step one, and concept number one is this vectorization concept. Now, what happens is the models take this tokenization, these word vectors, and then they update their internal weights based on these word vectors when you fine tune a model. And then so if we take our vectors in this particular instance of so in this instance, we have some sentences again. I love machine learning. Deep learning is fun. I love neural networks. Keras makes building models easy, and neural networks can learn complex patterns. And then so in this instance, what we're doing is we're first turning these into vectors. So it's not I love machine learning. It's like this, like 0.055, 0.3, whatever, etc. Right? And then we are converting and then we're training the model on this. And then so in this instance, we're training it for a few epochs. So we're training it for a few times. And then we're looking at the loss rate as we train it here. And then we can see that the model has learned the embedding for the word love in this instance, which is this particular embedding in this particular string of numbers. And then so we have now updated our model so its internal weights now know this, right? This is now a part of the model. It is internal in the model. It understands this like it's a part of its brain, essentially. And then so the difference then between rag tuning and fine tuning is that in rag tuning, we don't take this step. If we're whatever we're feeding the model, it never gets like embedded into the brain of the model, right? And then so in this instance, we have an instance of rag tuning. So here is a demonstration of rag tuning where we have essentially some sentences. So artificial intelligence is transforming the world with innovations. Quantum computing is a new paradigm that may solve complex problems. Swarm intelligence mimics collective behavior seen in nature to solve problems. reinforcement learning is a type of machine learning where agents learn by taking actions, and machine learning models rely on data to improve their predictions. So again, what we're going to do is we're going to vectorize these sentences, right? The model doesn't get these sentences, it gets something like this, and then it gets a bunch of this, right? And then so based off of this, it does this, and then what we're asking it to do in this instance is to retrieve some sentences in this instance, and then tell us what is most closest to our query. So in this instance, our query is, tell me about quantum computing and its future. And then it responds, quantum computing is a new paradigm that may solve complex problems. And it gets it from here, right? And then it's just essentially going through the vectors and then predicting the closest vector to our query. Our query in this instance, it has quantum computing and it's talking about quantum computing. And then this sentence that it has access to, or this vector that it has access to, is also talking about quantum computing. So it just pulls that vector, right? That's all it's doing, is just going through, okay, here's the different vectors that I have. This vector most closely matches this vector. Here you go. Here's what you want. Very straightforward, right? And then so here's a kind of breakdown as to exactly what's going on here. We're just creating a document, we're retrieving the document, and then generating a query based off of the document, and then the model is querying and retrieving that. And then so in this next instance, we're taking that a step further, right? We're taking a data set in this instance. So we're creating this into a data set, all of these same sentences, and then we're vectorizing them. But then we're going to train the model directly on these vectors. So we're going to essentially feed this to the model and then make it internalized inside of its brain, right? And then when we do this, what we can see is that by just feeding the model and feeding it to this simple model one time, it's not able to parse out what exactly to do with this. It's a 50-50 coin flip. It doesn't know. Like, we're asking it essentially in this instance, is AI is reshaping the industries? Is this related to AI? It says yes. And then we say the economy is struggling in recent years. Is this related to AI? And it says yes. Obviously, that second one is not related to AI. So it's not picking up and understanding exactly what we want it to learn in this instance. It's not updating its weights enough in this instance. So we would go through and then we would fine tune the weights of the model in this instance. And then so this leads you probably to the concept of understanding exactly why a lot of people prefer RAG tuning over fine tuning, because this is harder to pull off in this instance, right? You're getting the model to actually learn and internalize this information, as opposed to just saying, hey, grab these vectors that are created and then just tell me what vectors should go in there, as opposed to this. But what happens a lot within this is that this is more simplistic overall, right? And then so when you're dealing with more advanced queries, things like that, there's a lot more room for error in this as opposed to this. If you start getting this accuracy up to 90%, then you know that the model is actually internalizing this information, right? We know here it's not. But so if we work on this and we get this up, then that's where our fruits of our labor come in. And like, to me, like, a lot of people want to skip this step. They think that this is not necessary, and they go here. And then they wonder why models aren't as effective, and then have issues, and then don't have 100% of the outcomes that they're looking for. It's generally speaking, they can't, or they're not willing to go into these steps. And then so it's just, again, the difference between creating vectors and having the model actually update its embeddings based off of the vectors. Either way, with both RAG tuning and fine tuning, you're creating vectors, no matter what. It's just taking that additional extra step of actually having the model updating the embeddings. That's all the differences between RAG tuning and fine tuning. So if you like this type of content, please like and subscribe. Thank you very much.